welcome to this webinar on requirements completeness with requirements quality analyzer and IBM DOORS. The content of today's webinar is as follows. I will start with an introduction about myself, about my company, and about the tools that I will present today. Then I will address the problem, the issue of requirements completeness, by far one of the most challenging problems and topics in requirements quality. Then I will show you how to set up completeness metrics in requirements quality analyzer and how to check completeness in this tool. And I will show you a live demo just to get into the questions and answer section of the webinar. Remember that you will be mute all along the webinar, and but you can ask your questions in the chatting box and address your questions to the reuse company and not to me. This webinar, as I said, will be recorded, and you will find we will forward you a link to the recording in just some few days. This is myself, Jose Quintus. I will be the presenter and the host of this webinar today. You have my contact information in this slide, and I work for the reuse company as a chief operating officer. The reuse company is addressing or leveraging systems engineering through traceability, retrieval, and quality. All of this is addressing the reuse topic by means of repositories, ontologies, and assets within these ontologies. The tools that I will be using today for this webinar are mainly on the left-hand side of the screen, requirements quality analyzer. This requirements quality analyzer is a tool that allows us to set up what are the rules to be checked during this completeness assessment of our requirements. Then we will find that some of these completeness rules are based on knowledge that are represented in our knowledge base. So I will be needing a knowledge manager, the tool in blue here, just to formalize this knowledge to help us as input parameter in this quality checking based on completeness. And during today's webinar, I will not mention RAT at all. So you have some other webinar recordings available describing this of the tool. So I will focus on RQA mainly and a little bit on knowledge manager. These are the three tools that we are having in the market today. However, very soon we will be launching a new version of our tools, including new tools and new features. So I would like to invite you to join us here in Madrid for our TRC forum. This is going to be held in 2 weeks from now, on the 30th of November and 1st of December here in Madrid. If you want to join us, just visit our website, or in the slides that we will be sending to you, you can just click on the register here at the bottom just to access to this and to join and register to this event, to this conference. So speaking about requirements quality, requirements completeness, of course, we all know that probably the quality of our projects has to be improved in some ways. And according to this Coarse report, there are a number of different factors that are key for the success of our projects. And some of them, around 50% of them, are somehow related to requirements engineering and requirements management. However, in the very same report, the standards group is also showing not the success factors, but also the failure factors. And what is impacting is that completeness is not in the list of success factors, but however, if we address the failure factors, the most important failure factor in our project is completeness of requirements. So somehow we need the help of tools, and we need to train our people just to tackle this important issue in our requirements, right? So the topic of today's webinar, as I said, is completeness, and according to the Webster Dictionary, completeness is something that is absent or lost. It can be that requirements that we never collect or elicit from our stakeholders, or it could be also requirements that we collect from them, but somehow we lost the track. So as you can see here, missing in action. According to the INCOSE guide for written requirements, if we follow the definition of requirements completeness, we find that the requirement set is standalone such that sufficiently describes the necessary capabilities, characteristics, constraints, interfaces, standards, regulations, and or quality factors to meet the entity needs without needing other information. And behind this definition, we find minimum and sufficient, because somehow completeness is the counterpart of necessity, which is another quality criteria to be addressed for our requirements, right? So why starting with a complete set of requirements is key for the success of our projects. Of course, requirements are addressed in the main or in two of the main technical processes in our projects. However, the requirements that are collected and managed all along these two processes are the input, of course, for the definition of the architecture, design, system analysis, and implementation processes as well. But it is not only that requirements are impacting on these other processes, that you also deal with requirements when you proceed with agreement processes, acquisition or supply chain. All of this is also based on managing requirements, complete requirements if possible, right? Of course, verification and validation is the completeness of our requirement set is key for these two processes, verification and validation. And many other processes, such as the impact of requirements in terms of the risks that we are following by addressing this or this other requirement, or of course you cannot properly plan your project and you cannot assess and control your project if you don't start with a complete set of requirements. So having said that, I understand that we all agree that we need to start with this complete set of requirements. So let's check how to address completeness in our requirements. And to me, it is all about asking the proper questions. So many times when we try to identify our requirements, we are pretty much focused in one specific dimension. Most of the times we are thinking of the capability to be given to the users of our systems. So, but user is, according to this very interesting book, Discover to Deliver, user is just one of the 7 dimensions for our systems. We have to deal also with interfaces, actions, data, control, environment, quality attributes for our system. So if we want to end up with a complete set of requirements, we have to ask questions on all these different 7 dimensions. And when it comes to define questions, we can, in this slide, you can find lots of questions. What triggers our system to do whatever action? In what system states shall the system operate? What are the performance requirements related to the system? What is the state? And so on and so forth. So including one of the main sources of missing requirements, which is taking use cases and just focusing on the sunny day or happy path and forgetting about other rainy or not so happy paths in our or scenarios in our use cases. So this is key to avoid missing requirements. Other topic that we have to address is involving stakeholders in the elicitation of our requirements. So we think many times of stakeholders as the users of our systems, but sometimes it is not only users of the system. We have to address other layers in this onion, such as the stakeholders in the block of containing systems or the wider environment, which are all those stakeholders somehow impacted by a system or impacted by a project. So all these are suitable or are eligible to provide requirements for our systems, and we have to consider all of them if we want to end up with a complete set of requirements. Regarding all the dimensions, it is clear that many times we focus on the functional aspects of our requirements, and somehow we skip some other dimensions, performance, interfaces, mission, or verification, or this is just an example of a taxonomy of different types of requirements. This one is based on NASA, but you can find different other taxonomies, including different types of requirements, and safety and some others are key for the success of our projects, of course. Regarding the life cycle, it happens pretty much the same. Most of the times we are in our requirements focused on how our users will be using the system. However, we skip somehow requirements for the support area, or requirements even for the retirement. We have to consider that in most of your industries, you are dealing with systems that are not software. It is something other than software, and you have to think also on the retirement of these elements, right? So it's important to find the requirements for these other processes in the life cycle as well, right? Regarding other dimensions as well, many times our new systems are just are addressing the retirement of the old system and the replacement with a new one. And sometimes we have to consider the requirements that come up in the transition from one system to the other. These other requirements we have to address and to manage these other requirements as well if we want to finalize our projects with a complete set of requirements. However, requirements completeness is not only about how to identify a complete set of requirements, but sometimes we can also address requirement completeness for individual requirements. So for each of our requirements, we have to consider that it's not only the action that we expect for our system to perform. It is sometimes that we need this action to be performed when a specific trigger is found in our system, and but only when some specific preconditions are found. And of course, most of the times when we perform one of these actions, the system comes into a new condition that has to be stated in our requirements. So if in order to write properly a complete requirement from the individual point of view of this requirement, we have to address all these different blocks of the requirements, and not only the action itself of the requirement. And regarding completeness for individual requirements, it is not only the definition and the textual part of the requirement. It is also that missing links is contributing to the completeness of the requirements and the set of requirements, and also attributes as well. So missing or empty values for some of the attributes can make our specification or our requirement difficult to be ranked, or difficult to be classified somehow, or even difficult to be verifiable. So we need to provide all the needed information for all these attributes to end up with a complete set of requirements. And sometimes some of this, the management and the checking of some of these attributes can be a little bit tricky, because if you follow this box that I have included in yellow, this is coming from the ECSS standards from the European space industry. We have some, let's say, consistency checking for some of these attributes. During this webinar, I will not be showing you how to address this from the consistency point of view, but of course we have for the webinar recordings in our website where you can check how to address this kind of consistency checking as well, right? And remember also that completeness is not only about requirements, but it is also about other documents such as dictionaries, models, traceability matrices, stakeholder matrices, and so on and so forth. So completeness is of these other types of artifacts is also a must, right? So there are here a kind of summary, some ways to tackle requirements completeness using, of course, the appropriate list of different checklists for types of requirements, stakeholders, and so on and so forth. Reusing requirements is also a means of reducing missing requirements. Improving communication with stakeholders is key for the success of our projects as well. And of course, this is based on improving the communications skills of our business analysts and requirements engineers. Finally, establishing a formal inspection process is also key, as it is the consideration of the elicitation process of requirement as a kind of iterative and recursive process, and not only focused at the very beginning of our project, right? So this is just the introduction to the topic, and now the second part of the webinar is on how to address this topic using a software tool. This tool is Requirements Quality Analyzer. I believe that most of you are already familiar with the Requirements Quality Analyzer. This tool and in this tool set, let's say, including the other tools in the Requirements Quality Suite, we normally classify the requirements quality metrics in three main dimensions. We use correctness metrics just to check the quality of individual requirements, while we address consistency and completeness for sets of requirements. In today's webinar, as I said, I will be focusing on completeness for sets of requirements. However, I will also address a little bit the completeness for individual requirements. All of these can be based on the standards or in the INCOSE guide for requirements, but there are plenty of other rules that has to be analyzed when verifying the completeness of our requirement sets. So this is Requirements Quality Analyzer. I will just spend some few slides just to introduce you the topic before I use a Requirements Quality Analyzer in a kind of live demo. So normally, when it comes to the definition of the quality rules, most of you are probably focused on the correctness dimension of the quality checking, and this is why you are normally using these requirements metrics in the first block here, correctness. However, today I will be focusing on completeness, as I said. Probably what you will find when you start your RQA database out of the box is that you have plenty of correctness metrics. However, when you move into completeness, you find the completeness set kind of empty, right? So it is done on purpose, and the idea is that all these completeness metrics that I will be presenting today are what we call parameterized metrics, meaning that you can instantiate just by right-clicking on this empty list. You just right-click on the list and you add your metrics following one of these different types that I will describe in a minute. And as soon as you start creating or adding new metrics, you will find the complete set of metrics for completeness, let's say, right? So let me go one after the other. The first block are what we call terminology completeness, and this is the different metrics that we can instantiate in this for this type are addressing questions such as are we involving all the different systems and subsystems and components and parts and so on in our requirements, or are we reacting under all the different states and modes of our systems, or are we representing in the high-level requirements, are we representing all the different stakeholders and users of our systems? Or does your requirements, do your requirements still contain TBC, TBD, and so on? Or do your specs include the counterpart for all the actions involved in the system? Many times we can think that if we need a system to accelerate whatever, and we probably will be needing something or some other requirements to decelerate or break whatever other component, right? So it is very easy in Requirements Quality Analyzer to set up a set of dictionaries, just allowing you to check that every action is coming also with the counterpart of this action. Or if we address a number of specific actions for our system, when we decompose and we allocate requirements in the different subsystems, we expect that at least the same set of actions are somehow represented. If we take all the different requirements in level X+1, we expect at least the same number of actions that are represented in the upper level document, right? So all these can be addressed, as you will see in a minute, with the terminology type of metrics. Well, then the second block are those rules based on relationship and models. The idea is that most of the times requirements are coming together with models, and the consistency between requirements and models is key. So if you are representing in advance, for instance, all the elements in a product breakdown structure, then we could be expecting our requirements to at least to name all the elements in this PBS, right? So very quickly we can not only identify all the entity names in the PBS, but also checking whether we are establishing or we are stating all the requirements that are representing somehow the architecture of our system, or if we identify requirements that somehow could be in need of having some sort of interface, we can check whether this interface is properly set up in a XML model, for instance, or similar for the transitions among states in our state charts. If you use UML or XML state charts, we can check whether the requirements in our specifications are conforming with the transitions stated in that in the models and the other way around, right? So all these can be checked thanks to metrics in the completeness area of requirements quality analyzer. The following set of metrics are based on properties. We are, most of us, dealing with physical systems every day, and all these physical systems are ruled by properties and natural properties most of the times. The length, the weight, the pressure, the power, whatever. So the idea is that if we somehow represent all these properties in a XML diagram, it is key for us to check whether or not all these different properties are properly stated in our textual requirements as well. Today's webinar, as I said, is based on completeness, and we also have the counterpart of this set of completeness rules based on properties. The counterpart is checking the consistency of these rules. The previous webinar that we presented in the Reuse company was about requirements consistency, and I would like to invite you to follow the link that you can see here on the screen in case you didn't follow this consistency webinar. Following block are metrics based on patterns. Sometimes, as I mentioned before, we tackle one specific dimensions for our requirements, let's say functional dimension, but we skip all the dimensions, so let's say safety, for instance. So with the help of patterns, and for us a pattern is just a sequence of the different elements conforming a well-written requirement, we can identify what type of requirements you are dealing with for each of the different requirements you write. And by matching or conforming with patterns, we can check what types of requirements you are not addressing in your specification. So if you are not addressing, I don't know, let's say safety or security requirements, then requirements quality analyzer will very easily identify what are those types of requirements that you are not addressing. With regards to links, the tool also provides you the capability of checking whether your requirements are linked to high-level or low-level requirements, or if you are using also other kinds of links to verify your requirements, then it is going to be very easy in our tool to check whether all these links are properly established as well. And as I mentioned before, we think that requirement reuse is key to avoid also meeting requirements. We can think of two different types of requirements reuse. On the one hand, we have the more strategic reuse. We can name it coarse grain reuse. This kind of reuse is based on requirements libraries, parameterization of requirements, and so on and so forth. So normally, these capabilities are normally provided by standard requirements management tools in the market. And in some specific cases, there are also even product line engineering specific tools to tackle variability models or feature models and so on. So with our tools, at least today, we are not addressing this coarse grain reuse. However, we do address the fine grain reuse in terms of implementing a set of semantic search engine just to identify similar requirements in previous projects, and thanks to the traceability between these requirements and other requirements, we can easily identify other requirements that might be somehow missing. So in this example that I'm showing in the screen, you can see two different requirements coming at, in this case, at two different levels, and how even if these requirements are written following different structures and are written following different keywords and sentences, with our tools we can very easily create knowledge representation in terms of a semantic graph of these requirements. And with the help of information in our knowledge bases, let's say information in form of taxonomy, saying something like the system has a child which is an electromagnetic device, and this has another child called electromagnetic sensor, and radar, and so on, or clustering different actions by the meaning. Actions meaning somehow the detection of entities such as identify, discover, detect, find, and so on and so forth. We can very easily come up with this knowledge representation, meaning that these two different requirements could be represented somehow with the same semantic graph, and thus our tool will find this when looking for similar requirements. And this semantic search engine is also key to reduce the number of missing requirements in our projects. And finally, the last type of rules in our system are what we call the custom metric. And it is meaning that somehow we are not intending to cover all different dimensions with the previous metrics that I was presenting, and somehow we offer you the possibility to come up and code your own metric. So there are plenty of different ideas that you can have in order to help our specific needs with regards to requirements completeness, and we offer you the kind of backdoor for you to put your code inside of RQA and implement your own custom code metric. We have also some presentations and webinars on custom metrics as well, right? Just check our website if you want to find more information on this topic. Well, now the final conclusions before I start my demo is, of course, we have to work out the appropriate processes, techniques, tools, and skills, starting with inspections process, reuse process, elicitation and inspection techniques, requirements management and traceability tools, checklists, patterns, prototypes, and of course, communication is key to avoid missing requirements. Soft skills and assertiveness are key for the success of our projects. However, what we find is that this is not enough. Normally, our specifications are huge, are too large to be tackled by individuals. So the help of tools is a must. We need tools that could be analyzing thousands of requirements in terms of some few seconds or minutes, and identifying missing requirements just quickly and accurately. And this is what we have with Requirements Quantizer. And this is what I will be presenting right away in this live demo. So let me go now for the tools. Well, this is Requirements Quality Analyzer, and I have selected a DOORS module just to have different examples for all the metrics that I would like to present. So as you probably already know, in Requirements Quality Analyzer, you have part of the tool just to check the quality of your requirements, and the last block is to set up what are the rules to be checked, right? So I have in this database 8 different set of rules. Let me open these ones based on completeness. As I mentioned, normally our databases out of the box implement a large number of correctness metrics and probably no completeness at all. In this example, I have rules in this block of correctness, and these are the rules that I was mentioning before about the completeness of individual requirements. I have addressed these check-ins based on correctness metrics. And for the completeness of a set of metrics, I have created these other requirements. These other metrics. Just to put you the example before we go to the actual assessment of the quality of our requirements, I have created 7 metrics for the completeness, for checking completeness of the entire set of requirements. I would like to name in this document all the different actors in our systems. So this metric is based on dictionaries managed in KM or managed in requirements code analysis server as well, where you can establish what is the list of different actors. You can name your actors, and in the end, you can, with the help of this metric, you can check whether all these different set of actors are at least named and used in your textual requirements. With regards to interfaces, what I have done is I am using the capability of RQA to connect to modeling tools, and in this case, the modeling tool is Knowledge Manager, but you can also provide models in Rhapsody or Papyrus or other SysML modeling tools as well, especially with the launch of our next version that is expected by the end of this month. We will have the capability of connecting live to UML and SysML models just to check whether the requirements, as you establish these requirements in textual form in your requirements document, are conforming with the interfaces that you provide in your models. And similar for the following 2 rules, where in this one we will be checking whether or not all the different systems and subsystems and components that you identify in your requirements, when it comes that you use SysML to identify different states in a kind of a state chart, the idea is checking whether all the different states and modes are properly addressed in your textual requirements. So this rule is connecting both requirements and models. And similar for the product breakdown structure, we are checking with this rule whether whether or not all the different structural decomposition or architectural decomposition of your systems in SysML are properly addressed in textual form in your requirements. This one is my metric based on checking properties. In these models, I have identified a set of properties for my physical systems. Could be the power consumption as this example, or could be whatever other, the weight, which is normally also established in both in models and in textual requirements. And the idea is checking whether or not all these properties are identified in the textual requirements as well. Then this one is based on checking whether all the different system and system elements and components and parts and so on are also represented in our requirements. It is important to mention that when you connect, in this case, I will be connecting to IBM DOORS. You can pick one specific module and check completeness for this module. However, RQA also supports the idea of aggregated modules, meaning that you can pick a set of different modules. We can put together all the requirements in all these modules in an automatic way for you, and we can check completeness considering all these set of different documents and not only one individual document. And by the way, most of these rules only make sense when it comes to joining together different documents in one unique metric, right? And finally, the last rule that I have identified is one based on checking whether or not all the different patterns that we identify and all the different patterns that we expect in our requirements are eventually used in the definition of our requirements, right? So these are the 7 rules as a matter of example that I have created to analyze the completeness of a document or a set of documents. As I mentioned before in my slides, you can even instantiate new rules as you wish, following the different types that I was mentioning before. And the last block here, as I also mentioned, are the custom code metric, where you can just put your code and you have a new metric fully integrated in the RQA ecosystem of different metrics. So these are the rules for sets of requirements, as I said, but I have also some other rules to check completeness from the individual point of view of each different requirement. So in my example, I want all my requirements to have a value for the priority attribute. So in those cases where I find a requirement without priority, then the tool will identify this requirement as somehow incomplete requirement. I also would like to check whether all these requirements are having a specific verification method. And this, according to my definition of this metric, this is a little bit tricky because I have you can play around with different configurations of for the metric, including the conditions to be met, right? In this one, missing links is also tricky in the definition because what this metric is doing is the metric is just checking that all requirements in this document might have a link within this link module, drives module. However, if you have the appropriate rationale in your requirement, then this rule is not analyzed. So this is just an example on how you can come up with complex metrics, not only following what is the main block of the metric, but also under whatever specific condition. So only when this condition is not when this condition is met, then the tool will be analyzing this. In this case, the number of in or out outlinks in this case, right? In some other cases, when you establish the type of your requirement as a performance requirement, we would like to find the performance information, in my case, at the end of the requirement, right? So this is based on patterns. Remember that patterns are created and managed in our tool Knowledge Manager. So here, if you check the complete set of different patterns, some of these patterns are just to represent an action, a requirement from the performance point of view. So we can deal with the identification of all the different patterns that are conforming or addressing the performance information of our requirements, just to check that if you establish your requirement with the type performance equals true, and you don't, in the case you don't follow the specific performance information, then the tool will identify this requirement as a poor written requirement. Of course, as I mentioned before, if your requirement is including TBD, TBC, and so on and so forth, so it is not this requirement will not cannot be considered as a complete requirement. So in this case, this rule is based on just the identification of keywords within a list of incomplete keywords, which is also managed in Knowledge Manager. And the last of my metrics is. Sometimes you want to deal with the tolerance for one specific physical property. In my case, I want all the requirements dealing with the flow of air or flow of water to be to mention also what is the tolerance, a kind of plus minus and then a number, right? In the case you are mentioning the flow property in one of your requirements without providing the tolerance, and this is just my example, probably it is not fully addressing your needs, but in this case, I will be identifying these as poor quality requirements from the completeness point of view. Well, once you finish with setting up the different metrics in RQA, I agree with this definition. Then remember, you just link this rule set to one of your documents, or as I said, you can put together using our feature of aggregated modules. You can pick different modules to work with a set of different models all together. In my case, just to make it shorter in time, I am just dealing with one specific document. So you just establish, okay, these are the set of rules that I want to follow for this requirement, for this document, sorry. And then when it comes to the quality control, you just execute the analysis. It is a very short example, only containing 80-something requirements. So the analysis is done pretty quick, as you can see here. And then you have the results. For those of you familiar with RQA, when it comes to analyzing the correctness of requirements, this is the key screen for you to deal with the correctness analysis of your requirements. However, remember that today we are addressing all dimensions, not only correctness, but in my case today, completeness. So the idea is to move to this other screen just to check the different metrics that I have identified for completeness. However, remember that some of the completeness rules are not addressing the completeness of the entire document, but are addressing the completeness for individual requirements. So in the case of for instance, this requirement TBD, of course, the tool is telling me that the quality of this, the correctness quality of this requirement is poor, because this requirement is not complete. There is a TBD, so it cannot be complete. So we can check other requirements to realize that, for instance, this requirement cannot be complete from the tolerance point of view, because there is no tolerance for this magnitude for the flow of water. However, if I take this is exactly the same requirement, but now establishing what is the tolerance, and as you can see, the tolerance metric is analyzed as high quality. Of course, this requirement is assessed as poor quality because there are no links and there is no priority for the requirement. But at least in terms of the flow and the tolerance, the requirement is identified as high level. So this is how you can check the completeness for the individual requirements. And if you just go into the completeness section of our tool, then you find the 7 different completeness metrics that I established for the set of requirements in the selected module. And you can find that I don't have 3 stars for none of my metrics, so I have plenty of information missing in my requirements. If I click on the actors, then the tool very quickly is telling you that there are 3 main actors. I have requirements for the pilot, but I don't have requirements for the co-pilot, or I don't have any requirements for the crew. So this is a very quick way to identify what are the gaps in your requirements with regards to the users that you have involved, right? If I move to interfaces, then what the tool is doing now is the tool is comparing what you are stating in your textual requirements with, and it compares this information with your models. In my models, I have identified a number of different interfaces. In my very basic model, I have only 3 interfaces, and this metric is telling me out of these 3 interfaces, there's one between GPS and flight control system, and you have 2 requirements that the tool identifies as somehow requesting or demanding an interface between these 2 components. So, for instance, the GPS system shall provide the current position to the flight control system. This is clearly telling me that there is communication protocol or interface in this case between GPS system and flight control system, and this other requirement is pretty much the same. So if I click on the other, then it's telling me the GPS system shall interact with the flight control system as stated in IDR number whatever, table whatever. So these three requirements are demanding somehow interfaces between GPS system and flight control system, the first two, and between GPS system and fire control system. However, the tool is telling you, well, but there are no requirements needing or seeming to need some sort of interface between temperature control system and flight control system. So in case you miss a requirement, please provide the requirement. In case this interface is no longer needed, then please remove this interface from your model. In a similar way, we have identified for one specific component for the air conditioning system in my car. I have identified in my aircraft. So I have identified different states in a state chart, and the tool is telling you that there are no requirement putting the air conditioning system in fault mode. So probably you are missing some requirements in this, as I was mentioning in my slides, not so happy path of your regular operation. However, the tool is telling you that there are two requirements in the state of power safe mode, and there is one requirement in the case of standard mode, right? So it is a very quick way with this reduced number of requirements to identify what is missing. This one is pretty much the same. It's telling you that there are no requirements stating what is the relationship, the composition or architectural relationship between air conditioning system and heater. And this one is checking what are the different properties that I have identified for my components. I have identified, at least in this case, from this metric, the power consumption. And the tool is telling you, well, we have requirements addressing the power consumption for the fan, the compressor, the heater, the fan blade, but we are missing requirements to establish what is the power consumption for the air conditioning system itself. So something is missing as well, right? In terms of the system names, the tool can identify what are the names that you are using, the name of system that you are using, and what are, of course, the name that you are still not using in your document. And with this final metric, what we are checking is we have different types of requirements, and I have identified at least one requirements pattern for each of the different types. So very quickly, the tool is telling me, wow, you have plenty of requirements for other types. So 27 functional requirements, 9 physical properties, 6 requirements stating the architectural decomposition, and so on and so forth. But somehow there are no requirements dealing, for instance, with reliability or dealing with safety. So it is key for us to provide safety requirements in our specification. So very quickly, the tool identifies what are the requirements types that are not addressed in our specification, and for those that are addressed, you can find that probably there is only one performance requirement, which is too low. So for my example, it is okay, but for your real documents, one could be too low. So very quickly, you can identify what are the types of requirements that you are not following in your specification, right? And this is the end of my live demo. So let me go back to the slide for a minute. Let me go to the slide, which is somewhere in the other screen. So after the demo, just to say thank you for attending the presentation, and finally just to open the session for questions and answers. Yeah, the first question is asking, can we update the requirement in this tool? And the answer is yes. I remember that I didn't use the requirements authoring tool in my demo normally, because requirements authoring tool is the tool to address or to analyze correctness and consistency on the fly. While in order to analyze completeness, you need RQA to take the complete set of rules. However, even in RQA, you have the possibility to open one of your requirements and store or save your requirement back in DOORS. In my example, I will take, I don't know, there were another requirement having TBD, if I am right. Oh, no, only this. Well, suppose that now I know the answer to this. So it is very quick. You can write whatever you want, and you can save this requirement back in DOORS. So it is, of course, if you have the right to store requirements in DOORS. We have more questions. Second one is, is your tool able to only connect with Rocky files instead of a connection to tools such as DOORS? Oh, yeah. Yes, we are in this version that we have in the market today. There are together with the different requirements management systems that we can connect to. We also have the possibility to connect to XML files, right? In the next version, expected in 2 weeks from now, then it is more explicit, the link to RecIF, because in the list of available connectors, you can find RecIF. In this version, as I said, it is a little bit hidden because it is under the XML connector. Third question, if we update the requirement here, yeah. If you update here your requirement and then you open DOORS, then you will find your requirement. So it is in the Requirements Quality Analyzer. What you cannot do is you cannot create new requirements, but you can edit the requirements that you have. And as soon as you click on Save in DOORS, then of course this requirement when you open DOORS will be there with the changes. Yeah, this other question is related to tooling. Which other tools can we connect to? In this slide, I believe that this slide is the answer to this question. This webinar was on IBM DOORS. However, we can do exactly the same with PTC Integrity, with visual requirements, with OSLC, and we are capable of connecting to DOORS Next Generation using OSLC. But you can also do it on Excel, RecIF, as I said. And with regards to models, as I was speaking before, we are capable of storing these models not only in our knowledge management tool, but also and especially with the new version, which is expected by the end of this month, on the 1st of December. We can connect models coming from Rhapsody, Papyrus, NoMagic, XMI, for instance. So all these different models can be used for the checking of between requirements and models. One more question. You said that you could analyze system state charts. Where or in which tool do these state charts need to be defined? Yeah, good question. Today, in the current version of our tool, this connection is done in Knowledge Manager, in this let's say blue box that you can find here, right? In version 18, or let's say in the current version, what you have to do is you can import from SysML and store the information there in Knowledge Manager. In version 18, one of the most challenging topics that we have addressed is the possibility to connect live to a model in Rhapsody or Papyrus or XMI or whatever. So without the need of exporting and importing into KM. So there is no need to have physically all this model information in Knowledge Manager to be capable of checking the consistency of state charts or PBS or whatever. Okay, we have run out of time, and I believe that there are no further questions in the chatting box. So I would like just to thank you for being here with us. So thank you again, and I hope to find you here probably next year with more webinars. Now the list of webinars will start with webinars based on our new version. In this next version of our tools, we will be moving a little bit to model-based systems engineering. So you will find the possibility to check quality of models, and you will find capabilities for the transformation between requirements and models, and the other way around, or checking or verifying your requirements with physical models, or trace all these physical models and the requirements, and so on and so forth. So this is coming very soon in the next version that will be available the 1st of December. So thank you again, and please let's keep in touch for joining with all these other webinars. Thank you. Have a nice day.